Hi, everybody. My name is Alain Helaili. So I know the chairs are very comfy, so if you fell asleep during the previous talk and you didn't want to be here, it's a new one. This one is about GitHub. It's about GitHub. It's about how do we continuously deliver at GitHub. So I actually changed the title about chat-ups about GitHub. It's still the same talk. I have a couple of disclaimers first. I will not be handing t-shirts away after the talk. I've been asked for a lot of t-shirts. Sorry, don't have them. The other thing I wanted to share is also everything that starts with Git is not GitHub. So sometimes it's good to remind people that. Git was actually started by Linus Torvald 10 years ago now, and 11 years now, actually. And it's a core component of our platform. But we are just one contributor out of many, but one of the biggest contributor, obviously. And we created, on top of that, a platform called GitHub. Actually, GitHub started 8 years ago. And it was really a way for us to better collaborate, better using of Git, because Git is great. It's the best source code management that you can find today. But it's not great to share ideas. And the whole concept of our founder was really to find a better way to exchange ideas together and to not only send packages of code across emails, but to storing their ideas, storing their concepts, storing the discussions about the code, and keeping that through time, so other people joining later, the teams, could discover all that information and not having to get forwards of all the emails through the last years or so about the project. So that's when GitHub started, basically. Fast forward to today. GitHub is a very distributed company. You see, it's actually an old map of the employees of GitHub. We have that real-time system where we can see where everybody is on the planet. We are now 600 employees. This was a couple of months ago. And you can see that we are a super distributed company, and that's always been the case at GitHub. And there's a good reason why I'm sharing that with you, because it's part of the way we're working, basically. We want everybody to be where it makes the most sense for them to be, where they are the most productive, basically. So you can basically work wherever you want. We have people who don't have a home. They are going from one country to another, and they work that way. We got people who are living in an RV and going across the US, and they stop some places and they work from there. But our whole organization is based on the fact that we don't care where you are. You can work wherever you want. And we make sure that you don't need to be next to the coffee machine to be aware of what's going on in the company, right? The chit chats next to in the meat pack or next to the water cooler should not be required for you to be aware of what's going on. And it's a very important part of our culture, but I'll go in depth in that. So we have people all over the world. And you can see we got people in Hawaii, we got people in Australia, we have people in Europe, in Japan, and these people might very well be in the same team. So in one team, you could have someone in Hawaii, someone in Australia, someone in Europe. We have a team of 5 or 6 people, and these people should be able to work together. And again, regardless of where they are. And you can imagine that when you have such a distributed team, it's quite hard to have discussions. It's quite hard to do a stand-up meeting. It's even hard to do a WebEx. Right? You can have a good time frame for a meeting online that fits people who are scattered all over the world that way. So because of that, and it's just one reason out of many, but because of that, we decided that we needed to have a very written-oriented culture. So everything is written at GitHub, and we have a say that if something is not written, if something doesn't have a link that you can share, then it doesn't exist, right? Your conversation that you had next to the water cooler doesn't exist, or the decision you made in that meeting room doesn't exist if you cannot share the link about everything that was said during that discussion, and what were the reasons why you took that decision. And as a matter of fact, if you're using GitHub, are people using GitHub? Yeah? Oh, okay. If you're using GitHub, you know that everything you're doing basically has a link. An issue has a link, a pull request has a link, a comment in an issue has a link. So you can send a link with just that one comment, and everybody will be able to receive that link and see exactly what you are looking at when you send that link. So we took that concept very far, and it's very central to our thing. But we have other tools and techniques, but our main goal behind that is to be able to deliver and deliver quickly wherever you are and whenever it is. So this is a graph of the number of deployments we did in production, so on GitHub.com, in a given week. So that was in May 26th week. It was actually a 4-day week because there was a holiday on the Monday. And you see the number of deployments on GitHub.com goes almost all the way up to 480. 480 deployments in a given week on GitHub.com. I hope you didn't see that week a lot of, error screen, angry unicorns. That's what we have when there is a problem. Sometimes that happens. But we basically managed to create something which allows us to deliver whenever we want, seamlessly, without anybody seeing anything, any change, any downtime, any whatever on our website. There are good reasons for doing that for us. One of the main reasons being, I think we are number 56 in the ranking of the most popular website on the planet. We have about 40 million visitors per month. So you can imagine that we have a couple of servers in our data center. And what we figure out is that there is no way for us to be able to create a test environment that would work for that scale of traffic we're facing, for the diversity of traffic we're facing, and with all the components we have to go through for whenever we're serving one request. So our conclusion was the only way to validate some code, the only way to make sure that some code is production ready is to release it into production and see how it works. So that's why we're deploying so often. We don't have that many features that we need to deploy 80 times a day. But every time we're developing something, when we want to validate that, we push it to production and we see how it works. All right? And I'm going to show you today how we do that. What are the tools we're using? And actually, all the tools we're using, or most likely most of them, you could use them as well. I mean, there's no hard complexity over there. It's just a matter of organization. It's just a matter of thinking that you can do it. Then it's super easy. And so some people sometimes tells me, yes, but I'm a bank, I cannot do that, or I'm this, I cannot do that. We have a customer called the JPL, so the Jet Propulsion Lab, the guys who are doing the engines for the NASA. They want to do continuous delivery, and they do continuous delivery. And so it's really about thinking about the trade-off, because people always tell me, like, yeah, if there's a bug in production, what happens? Well, first of all, there's always bug in production. And how fast can you fix them? So when you have a bug in your jet that's going into space, what happens if you cannot fix it? What happens if you have one bug and, on the other hand, you can fix it in a couple of seconds? Well, maybe that's better, right? Because the jet goes back to its trajectory, and that might be better. So maybe you got more bugs in production, but you're fixing them faster. So, think about that trade-off. That might be better. And I think it's better for a lot of companies. So how do we do that? So what's our secret? That won't be a secret anymore because I'm going to share everything, obviously. But there you go. So first of all, and I'm going to go in depth about these 4 different points. But the first thing is we needed a common philosophy. And I mean, I urge you to start thinking about your team. And are we, in your team, are you all thinking the same way about features, about the way you develop? You might have a common workflow, but even in a given workflow, there is some room for people doing different things. So we have that common philosophy, and I'll show you that to you right after. Asynchronous communication. So I showed you that we are all over the planet. And being able to share information regardless of where you are, is super important. So that concept of asynchronous communication goes also beyond that, and we'll go over that as well. Continuous delivery, of course, we cannot do that. We cannot deploy that many times a day in production if we don't have a solid continuous delivery platform. And that goes through something that we call chat ops. So chat ops, you will see it's basically doing DevOps through a chat client. And it's fun, but it's also super useful, and I'll show you why. All right? So first of all, common philosophy. So that's what we call the Zen of GitHub. It's a list of things that we try to keep in mind when we're developing feature. And it's very simple. It's about like, okay, are we going to develop for 3 weeks and then start sharing this code with our colleagues? Or do we rather break down everything so we develop only for 3 days and start sharing after 3 days, but having more like pull requests open, for instance? So it's a lot of things that way, where if you're not doing all, if you don't go all in the same direction, then you're going to have some clash in the team at one point, and it's going to show in the code as well. And you can imagine that us being so distributed, you have many cultures, many ways of seeing things, many backgrounds. We didn't go to the same schooling systems, so there are a lot of differences between people on how they approach things and how they approach complexity, for instance. So it was super important for us to have that common view of things. So every developer at GitHub, we know that he should not work on, by himself on a corner for weeks and weeks and weeks before sharing something. That doesn't work in our company. It needs to be open. It needs to be short. It needs to be concise. We need to be able to deliver it quickly so we can iterate on that. There's no such thing about like a feature that we're going to spend years and years working on and deliver that and see that maybe it doesn't work, or it's our users don't want that. That would be stupid. So that's our Zen of GitHub. And actually, I told you earlier that everything needs to have a link that we can share. So if you go into https://api.github.com/octocat and you call that several times, you will have one of these sentences showing on your screen, and you can go through that on your own. So it's actually the first sample of our APIs if you want to try leveraging our API. So you can find all that stuff. It's public. So that's the first thing. Second thing is that asynchronous communication. And it's obvious that asynchronous communication is very important for a distributed team like ours, because there is no, time for a WebEx, there is no time for a physical meeting. It's not possible to have that. So that's the first reason why we started that way. But if we're talking to our founders, they will tell you that even when there were only the 4 of them, all in Silicon Valley, in the same office, they were hardly ever talking to each other. And there's a good reason for that. They were saying that if I'm talking to you while you're coding, I'm interrupting your flow. You were in dev, thinking about something, coding something, and I'm asking you a simple question that it's going to take you maybe 30 seconds to answer, even shorter maybe. But you're going to lose a lot of time. And some researcher did in-depth study about that, and they found out that it will take you about 15 minutes to go back to your regular coding flow when you're being interrupted. 15 minutes to get back to the speed of code that you were at before. You can imagine it's really big, right? The number of times you're being interrupted on a given day, it accounts to probably an hour at the end of the day. Because think about it. I mean, when you're coding something, you hardly ever have just one file. You're probably thinking about several files because you have split your logic and your data and your representation in different files, and you have that model in mind. And as soon as somebody is talking to you, that model gets flushed. It gets flushed like in the toilets, and you have to rebuild that stuff in your mind and restart, start back to where you are. So being able to say, okay, instead of interrupting you whenever I have a question, well, I'm going to, organize myself in a way that I might be able to wait for that answer at the end of the day, or I can give you 2 hours or 3 hours or maybe more to provide me that answer, and my colleague will send me the answer when it's convenient for them. So when they're done with something, like they've merged a pull request, for instance, and they're ready to, they have free time in their mind, they can start going back to Slack, going back to the pull request, going back to the issues, to start answering my questions and giving me feedback. And it's just as fine for me, because I had some other things to do anyway, and I can multitask, I can do other things, and the answer will come in a timely manner. Not right away, but I don't need that right away most of the time. So it's one of the great benefits of that asynchronous communication, and that really works whether you are distributed through the world or that you are all in the same room. The other thing is, very often we have meetings. And I mean, meetings is like, it's craziness. We have so many meetings. I had some customer once looking at a developer schedule, and he calculated that the developer actually is developing only 60% of his day. 60%. You paid for writing code, and you're just writing code 60% of your day. It's not that you're not doing any meaningful things for the other 40%. But what if we could give you back 20% of time of coding? Would that be great? Maybe there are some meetings where you drag the developer for an hour and he's really useful in that meeting for 10 minutes. And what about if we also could maybe get that information in a different way? Maybe, have a system where everything is open so everybody can grab the information they need to create their own report. And that's what we're doing basically at GitHub. GitHub, it's funny because it's a developer company for developers. So we are one of the few companies who really eats his own dog food. So it makes our life very different. And when we think about what we're doing, we're really thinking about how we can improve our day-to-day life. And it's probably, I hope, it's probably impacting your life as well as a developer. So being able to have more time developing, it's sometimes also like making sure that your manager understands the way you're working and that it doesn't like set up a meeting right in the middle of your day or your afternoon or your morning. Because if you have a meeting at 10 a.m., why are you going to start working out at 8 a.m.? Probably not that big refactoring stuff that's super useful, but that's going to be complex. Because you're just going to have like 1 or 2 hours of work, and it's going to take you 4 or 5 hours to really start that meaningfully. So you're just going to do some meaningless things or like less important things. It's because it's different for you to have 2 blocks of 2 hours or having 1 block of 4 hours. So educating the manager sometimes about when to schedule the meeting could save you also a lot of times, and that's the kind of things we're trying to think about, being conscious about, in order again to make our life easier and being more productive. So that all goes into the umbrella of the asynchronous communication. That's super important. And then of course we use our tools. So as I told you, we are eating our own dog food. And for instance, we are never sending emails to each other. We are never sending emails to each other. We are just creating issues. When I want to talk to somebody, I create an issue in a repo, and I got that conversation starting for that. And think about it. When you put information in an email, can you find it back 6 months later? Right? Can you look? You know that it was in an email. You know it's somewhere. You cannot find it. And think about also, all right, we discuss about that whole new refactoring stuff. We made decision. Somebody was good enough to take notes, send the notes to everybody in the team. And you have a new colleague coming 3 weeks later. What does he know about that stuff? How does he find that information? He won't. It's buried, it's lost. You won't find it anytime anymore. So that's why we're using issues. We're just using issues. You want to talk to something about, you want to share an idea, you just create an issue. And it sends emails notification, you can reply through emails, but it gets back into an issue. There are labels, there are metadata, and it's searchable. So you can relate back to that. And people who are coming in the team later, people who are away on vacation, they can catch up, they can discover the information. So it's super valuable. And then, I don't know if you've seen that. It's been released a month ago. You can now organize your issue in Kanban boards and working projects. So I don't know if you've seen that. We're super excited about that stuff. And it comes for free. And then we're using pull requests. So pull requests are also very interesting things. There are many ways to use pull requests the wrong way. I'm saying the wrong way, but I would say the not so optimal way. When I discuss with people, a lot of people are telling me that they code, they create their branch, the feature branch, they start coding on that branch, and at the end, they open a pull request to share with their teams and say, hey, can I have a code review? Well, great, but if the first comment of the code review is like, oh, I would not have used that stuff, I would not have used that framework, or I think you went in the wrong directions. Well, maybe we should have talked about that before, because you've been working on that stuff, you've made decisions, and if nobody agrees with your decision, then you might have lost a couple, days of work. And going back on that is probably a bad idea. And also, what happens if you're doing that you're asking people basically to discover everything you've done. They have no idea when they start the pull request, when they will start reading your code. Where do you want to go? What was your your logic? What was in your mind when you started that? So we're doing things pretty slightly different. What we do when we have a new feature to implement is that we open a new branch, of course, a feature branch, and we're probably going to create like a very small commit somewhere or like get things started, so we can just create a pull request, and then the developer starts sharing what it's going to do. It's not about what I've done; it's why am I opening these pull requests? Where do we want to go? What am I thinking about in terms of impacts, in terms of changes in the model, in terms of refactoring, in terms of whatever. I'm going to share first with other people what I'm planning to do, and then my colleagues can start jumping in the conversation and say, yes, and don't forget to do that as well, or maybe you should not use that stuff because we did something different somewhere else. You can imagine whatever conversation you might have. So it's happening. These conversations are happening before we start coding. So then, when we start coding, we know that everybody agrees on the direction we're going to. And when my colleagues have to do a code review, they pretty much have an idea of what they're going to see. They're not surprised by anything, and they can send me back some good information. And I'm maximizing their time at the same time. They know exactly where to go, where to look. They know what's important, what's less important. They are saving hours of code review per week just because they know already what we are talking about. And super important. The other important part is to make sure that you're not asking code review on 40,000 lines of code, because then your colleagues are coming and saying, "Looks good, go ahead," and then it's totally useless. I mean, when you're doing 40 lines, you have 40 comments. Well, that's maybe too much, but at least you have meaningful feedback. And I mean, code review is so important today. I don't know if you guys are using that, but from a quality point of view, it's great because you're going to be able to catch some bugs that you might not see otherwise, and that your continuous integration cannot see either. And you make sure so that the knowledge of the code is distributed through the team. Because sometimes you have these guys in charge of that part of the code, and they go on for vacations, they're coming back in 2 days, there's a bug. Well, let's wait for him to come back, because by the time I read all that code, he'll be back anyway, so let's live with that bug for now. That's not a great way of doing things. And what if he dies tomorrow, right? If you've been doing code review consistently, it doesn't matter if he dies. Doesn't matter. You get the code, you know it, you know the code base. And so it's a great teaching opportunity as well. What we're seeing is that younger people are learning by doing code reviews to older people. It's not just about the senior developer reviewing the junior's code. That's great. They can tell them things, they can teach them things. But with the junior guy reading the senior guy's code, they will learn a lot of things that they've never learned at school, and they can improve their own code by that. So everybody benefits from that. So it's really something that you guys should start doing more of. And it pays off right away. It's not a waste of time. I mean, some people still believe that testing is a waste of time. I've met some like very recently. So some people think that code review can be a waste of time, but honestly, it pays off right away. All right, so we're doing that a lot. And what we do also, and that's also something I encourage you on doing, is that we're sending back a lot of feedback to the developer. Right? The great benefit of Git, I think, and it's kind of a side effect, but it's still a great benefit, is that it's easy to create a lot of branches, but it's also easy to plug your continuous integration tool to all these branches. So whenever a developer is creating a branch, he creates a pull request, and that pull request, triggers a notification to the continuous integration platform whenever somebody is pushing some code, and the continuous integration platform can send back feedback to the developer. Right? You probably will do that already. But most people just get back one piece of information, like it's green or it's red. And you've configured your Jenkins with like 45 different plugins to get a lot of information back. And you just have one green or red. And that's it. So when it's red, what's red? Like, tell me about it. I need to go in Jenkins, look for it, look for my build, scroll down, oh, that's this stuff. I don't care about that stuff. And I've just wasted like 5 minutes to look for my error that I don't really care probably about. So that's a huge waste of time again. And remember, it's about getting some time back to create some new features. So what you can do is use the APIs that we offer, and you can send back some intermediate status. So, the linter is green, the compilation is green, the unit test is red. It's not just about something is red. It's this stuff is red. And is that stuff important or not? Well, you can decide on that. So you can say, okay, this status, for instance, the GitHub one, is required. So you cannot merge if that stuff is not green. That other stuff is not that required. I mean, it's good to have, nice to have. But if it's red, you can still merge. All right? It's your decision as a developer. And you guys can do that today. I mean, it's available. It's very easy to do. It's just some HTTP APIs. And you can really improve your whole CI system. Because the CI system is really about getting feedback to the developer. So while he's developing or she's developing, she can get more information, make better decisions, and go faster as well. So go ahead and do that. And what we've done also is we modify our Jenkins. So it's called Jenkey. It's actually open source, so you can download that. So we have a direct link between our pull request and our build status. So basically, when I'm clicking on the details here, for instance, for that build, I'll go there, and from there I can click on the pull request button and go back to my pull request, for instance. So I never have to do 3 clicks or even 2 clicks. I'm always 1 click away from my information, and I'm saving a lot of time that way. The other stuff we're doing is that we are using our deployment status as well. So that's another API that you can use, because probably when you're developing today, you have some environments that you can target before going to the live production environment. You might have a test environment or a QA environment or whatever other environments you can think of. And it's quite convenient to be able to know that somebody deployed that feature to some environment. Like, I'm a tester. I need to test something. I can go in GitHub. I can see all the pull requests being worked out. And I know that I want to test that one. It's important. That feature, we will really explaining that. I'm going to that feature. I'm scrolling down the history of that pull request. And I'm seeing, oh, I can click on View Deployment. It means that I will go to some environment somewhere where this code is running at the moment. And I can see for myself how it's running. And I didn't have to talk to the developer to get that information. I haven't been interrupting anyone to know that I can test that stuff. It's here. It's still active, because it could be a virtual environment that's been spun off automatically, or it could have been erased by some other deployment later. I know all this information and I can see it for myself. It's super important, super valuable. And when you're looking at the history of a pull request, you can understand how many times it's been deployed, which environments we've been through. I mean, you can really assess the release cycle that we went through to have that feature running. You can use that. It's, again, an HTTP API that we offer. All right? So super valuable. Let me skip that one. I'll go back on that later. Other things, again, about reporting without reporting. Again, that's you know, do you enjoy doing some reporting? I guess not. I mean, nobody likes that, but you still need to do that. You still need to get information back to the product manager, product owners on what we've been working on this week, what have we delivered. So that's kind of a dashboard where everything shows automatically. I don't know if you know that, but when you start a pull request, you can say it fixes and the issue number. So if your user stories comes as issues, you can reference the issues you are fixing in a pull request. And as soon as you merge a pull request, the matching issues are closed. So if you're working that way, your product owner just create issues, and they know exactly when you've been working on these issues, because there is a cross-reference automatically generated, and they will know exactly whenever you have closed or merged this pull request. Again, the best reporting, the one you're not doing, basically. It's the most accurate one, and it's very transparent. There is no more like, yeah, I think we are not far back, or we are almost finished developing that feature. Like, let's say we are 85%. No, I mean, you've done it or you've not done it, and that's very simple. All right, so that's all the tools we're using. But then, let's recap. Let's recap first. So what we're doing, we're creating a feature branch. We are adding very few commits, and we're opening the pull request right away. And then discussion happens, commit happens, more discussion, more commits. Review is happening as well in the pull request. And then we ship the code. All right, we still are on our feature branch. Master is over there. That's the big fat line over there is master. And this is a feature branch. And so we ship that code. So you can ship that code to, a QA platform, a test platform, whatever. But as I told you before, we happen to ship that to production. And in order to do that in a reliable way, because doing 80 times a day, that thing, there could be room for a fat finger or like some problem, or thousands of servers are involved in these deployments. There are multiple tiers, multiple databases, multiple router, proxies, whatnot, and we actually manage all these layers separately. I mean, a proxy at GitHub is some code created by GitHub because there is no Git proxy on the market, or Git router, so it doesn't exist except at GitHub. So we have to handle all these different tiers that you're going through whenever you're hitting the commit, the commit button or whatever. So we created Hubot to help us doing that. So Hubot is doing a lot of things for us. It's our there was actually an article on Wired about Hubot once. I'd love to have an article on Wired about me, but this is a robot, and he got that. It's been called the hardest worker of GitHub. It does everything for us. So it does our deployments, and I'll show you how it works. But it does also some more fun things, like it can get us some maps on Google Maps. It can get some images as well. So it just sits in Slack. We use Slack, but you can use something else. Because Hubot is an open source project. It's just a Node.js runtime. And it has adapters for a lot of different chat environments. So if you use HipChat or other stuff that I don't think of right now, you can use it as well. It's very easy, and you can create your own plugins. So we've created a lot of plugins, a lot of tasks that Hubot can do. We told him a lot of things. Some are very serious, some are less serious. So we can have like the food truck around the office. We just ask Hubot, and the truck me command give you that information. It can get you some animated GIFs, so it makes things a lot fun. It can, like, our salespeople, whenever they want to have some information in Salesforce, they don't go in Salesforce. They go to Hubot and they say, okay, .sfdc me, and they say whatever customer they want to look information for, and Hubot goes to Salesforce and gives that information back. What our thinking now at GitHub is that anytime I have to do something, anytime I have a script to do or a system to interact with, most likely the best way to do that is to go through a Hubot script. That way I don't need to log into any system. I'm just in my Slack environment, and it just works for me. Right. I don't need to know where it is. And the side effect of that is that all that work I'm doing, talking to Hubot, I'm doing that in front of my colleagues because we are in Slack rooms. And if I'm looking at a customer and somebody else is also interested by this customer, then we can, they can say, oh, yeah, I know why you're looking at that because, I had that discussion with that customer some other day. Likewise, and I'll show you that later, all our, Splunk, for instance, or our graphing systems, they are all accessible through Hubot in Slack. So when I'm troubleshooting something, I'm looking at, the response time of the home page, for instance. Everybody knows that I'm looking at that, and people can jump in the conversation and tell me things that I'm not aware of. And they would not be able to tell me that if I was looking at that on my laptop, being in Paris, for instance, when my colleague is in San Francisco and he knows about that. And I would maybe not have the idea to put him over in the conversation, but he just sees what I'm doing, so we can start that conversation that way. So another great thing with Hubot is it kind of listens to what happens. So we can configure Hubot to watch the activity on some repos for a given Slack room. So each team has its Slack room, and each team has its list of repo. And Hubot will tell me whatever is happening in the repo that I'm interested in my team Slack room. So whenever somebody is opening an issue or commenting or whatever, well, I know what's going on. So I don't need to watch some notification anywhere. I'm in Slack and I know what's going on over there. And likewise, if in Slack we're referencing an issue and we have a discussion in Slack about an issue, well, there will be a comment by Hubot in the issue saying, hey, this is a link to that conversation that happened in Slack. So I don't need to copy and paste discussions to send them back to the issue to keep the track of that. It's the cross-referencing is happening naturally. So I'm just using whatever tool I have to have that discussion. If my colleague is there, is available to chat, we can chat about that right away. Or otherwise, I would go to my issue and put maybe longer text of questions or thoughts or whatever else. But it's up to me to decide which tool I want to use because I'm not losing anything. I'm not afraid of losing anything by using one of the two tools. So it's pretty easy. And then comes the times where I want to deploy my code. So the developer who wants to deploy some code somewhere can just go to Slack, and again, it could be something else than Slack. I'm not trying to sell any Slack here. And he just asks Hubot, where can I deploy? So WCID is where can I deploy? And whenever there is a dot, it means it's a Hubot command. You could also use a longer form, would be Hubot, where can I deploy? But we made it shorter, obviously. And Hubot will list all the environments we have. And this particular command comes, it's open source as well. So you can use that command to list all your environments and give some couple properties to define, where they are, what kind of environment they are, and everything. So all that, up to there, it's standard. Anybody can use that. There's no problem. And so the developer will then decide to use one of these environments. So for instance, my colleague MDO decided to deploy the branch mobile_nav_experiment from the GitHub repo to the branch lab, which was one of our environments listed before. Okay, you just need to say that, and then Hubot is going to pick up that code and deploy that on the servers. I mean, then we have some, script. We're using Puppet, so Hubot is going to work with our Puppet environment to trigger the deployment, because Hubot is not doing much. It's more like a middleware, for instance. If we can put it that way. And so the deployment is going to be triggered, and a couple of minutes later, Hubot is going to come back and say, hey, this is available now, it's been deployed, and he got some message back from the deployment system, from Puppet here, about the location where this deployment can be seen, And that link over there, the mobile -nav minus experiment, blah, 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 that's what you will get on the pull request as well. Remember that view deployment button? That will show as well in the pull request. So the developer just need to click on that, and that's it. It's done. So you see, the great thing about that is any developer can arrive at GitHub, and 10 minutes later, they can start deploying things. They can't mess up anything here, right? It's hard to mess up that small workflow. So we've been able that way to deploy in our branch lab system. But then we want to deploy to the production environment because that's where things are really happening for us. That's where we test everything. So that's where we test everything, but we've tested everything before, obviously. We don't wait for the production environment to make the basic test. And so the production environment is a little trickier, right? You don't want two people to deploy some test codes at the same time. You want to make sure that one person goes after the other ones, and you want to make a couple checks as well to just to be sure, right? So the first safety measure we have is that only one person at a time can deploy in the production environment. So there's a queue. So you need to wait in the queue to be able to deploy anything. So the developer can ask Hubot, what is the status of the queue? Because if you have 25 person in the queue, you might decide to go back coding and come back later. So here we see that we have a couple of guys in the queue. Somebody is using the environment already, and another one is in the queue. So it's very manageable. So the developer can say, okay, queue me to deploy, QMTD, and it will give the reference of his branch. So Hubot can, remember that this guy wants to deploy and come back to him later. So you see the time; it was 3:43. It's a real deployment, right? I'm not making up anything here. So it was 3:43 and 3:54. Hubot comes back and say, "You up? It's your turn now to deploy things." So you see, it goes pretty quickly, right? You don't want to have people hogging the production environment for hours and hours. Again, we have a lot of requests per second. So if something goes wrong, we can see it pretty quickly. We don't have to wait for users to come; they always come. So that's why our turnaround is pretty short. And on top of that, and I'll show you that later, the developer needs to be there physically in front of his screen to monitor everything that's going on to make sure that his code didn't break anything. So 21 minutes later, the developer can say, okay, I want to deploy my code to this environment, prod/canary. So it's a subset of our production environment. And then Hubot makes a couple of checks. So Hubot checks, for instance, that your branch is not behind master. Because if you are being master, you're going to remove some features. That would be unfortunate. So there are a couple of checks that way. We will check the status of the CI. So remember earlier, there was some required status, some feedback from the continuous integration. Well, we're going to double check that the developer has the right and to deploy given the status of the CI on his code. But that's all very important check to make sure that we're not breaking anything. Okay, you were going to do the job and get back to the developer a little bit later. So it was actually less than a minute. And to give back a list of all the servers that have been impacted. So, the grayed out production servers. And that's it. Again, I can't break anything doing such thing. It's very hard to break that workflow because it's so simple. Anybody can do it. So it's in the production environment. It's super easy to check. Then the developer, most likely, nobody will see what happened over there. Nobody will see if there is a new feature, a new button, or whatnot. Nobody will see that because we have some feature flags and we have an application, it's open source as well, you can download it, to manage our feature flags. So we can decide that this button will show only for these and these people on this and this repo and only, during a couple of days or whatever. I mean, we can really decide from an external tool how that feature is going to show up. So that way we can introduce a lot of new things without anybody noticing. and then we can open the knob later and say, okay, now everybody can see it, or now only this organization can see it. It's very easy to manage. So we've deployed onto our Canary environment, and now we want to deploy to the production environment. So likewise, the developer still has a lock on the production environment, so he can still use it for doing other things. And he can decide to deploy to prod, and again, same thing happens again. We just need to deploy branches at GitHub, basically. If something was going wrong, so if the developer decided that the deployment on Canary was not good, the code was not good, what he needs to do is just deploy master. It deploys master, it's a rollback of the feature it just created, and that's it. So either I'm deploying a feature branch, either I'm deploying master, and I always go back to a solid state that way. Easy. You can't mess it up. So what we ask the developer, though, is that he needs to monitor what's going on. So he has been able to deploy his code, but he needs to monitor what's going on in the production environment, because he's the most likely person to understand the exceptions that are showing up or the problems that can appear, because he knows what kind of code he's been deploying. All right? So we give him some tools, and we actually give him all the tools he needs to monitor everything. So there is no like one team has the monitoring, one team is coding. It's like everybody's monitoring. And everybody has access to all the monitoring tools. Because if you don't know what code has been deployed, how effective can you be at monitoring or at diagnosing what's going on in the system? So we have that tool, and we have another tool called Haystack. So in a haystack, obviously, you're looking for needles, and every exception is called a needle. And what you see on the timeline here is a picture of all the engineers that have deployed something. So if you see in the timeline, and this is the response time of the pages in GitHub. So if you see a problem in between two deployments, well, you know that the one on the left is the person responsible for that deployment, and you can obviously contact that person. But you see directly the pull request or the compare page on the pull request of that deployment. So you can isolate immediately the amount of code that has been deployed through, during that deployment, and you don't have to, investigate all the code base you have, or like the 25 feature you released every month in production. You know that it's only one feature, one set of code, and it's very fast to then read through that and find the bug, right? You have just one pull request to examine, not 25 of them. So it's really, it's a lot faster to assess any problem, and it's a lot faster to diagnose a problem, it's a lot faster to roll back eventually, or to fix the problem. Right? It's still going back to that, that jet that goes in space. If you can fix the problem quickly, then it's not such a problem anymore. But if you cannot fix it, then you're screwed. So we have that, and then what happens also is Hubot, again, is listening to our different systems. So we don't have somebody in front of Nagios, for instance, or some other system you might use to watch the alert. Hubot is doing that for us. And think about it. Whenever you have something to diagnose in your production environment, you have an incident for a given app. You always go through the same indicators, right? You're checking, you're checking the response time, you're checking the CPU, checking, all these systems that are part of your application, what the status. There are all these steps you're going through almost every time you have an incident. Well, if you're doing it all the times, it means you're wasting your time, because you could automate that. So whenever we have, like, for instance, this incident here, this particular like haystack slow queries per minute, well, Hubot is going to report us in Slack that there is a problem, but Hubot is also going to create the issue for us so we can track that. Hubot is creating the issues, putting the right labels, putting the right information over there, so the name of the incidents, the description of the incidents as it's been recorded somewhere. But also it's going to grab the status of all the systems we're usually looking at. So instead of going to system A and B and C and D to get all the information, while Hubot is doing that, put all that information in an issue, is going to look at some graphs as well, again, put that in the issue. So whenever some engineers need to diagnose that issue, it goes to the issue, that problem, sorry. We go into the issue, and we have all the usual suspects. All the things you always do when you're diagnosing something, it's here. well, you might need to go further, right? The solution might not be there, but you actually have all the basics you need to get started, and then you need to, start doing your thought process and investigate that stuff. But the usual stuff, and here you see it will have been like 3 or 4 different systems that I will need to go to get all that information. Everything is right over there. Likewise, I told you if I need to look into my logs, we have Splunk that is ingesting all our logs. I'm just going to Slack and I got some commands to query my Splunk logs. And again, I'm doing that in front of my colleagues. They can see what I'm doing, and they can jump in the conversation and tell me, hey, I know what you're looking at, or that kind of problem is happening when you're doing this and that. We're saving time, and we have conversation about the problems. Or junior people can just sit and enjoy the Slack discussion and see how other people are diagnosing these kind of problems, and they can follow their thought process. And they can do that, we can go back in time, so people can look at an incident that happened like 2 days ago and understand what was the thought process of the people and learn from that. Likewise, graphs, everything is available for that. So let's say everything went well. We can now merge with master. It's only after we have validated that something works in production that we're merging with masters, because master should always be the branch that you can redeploy whenever there is something wrong. So master should be only validated code that you can redeploy whenever something else is going wrong, basically. So we merge with master. So the developer just click on the merge button, and it's, as you see, it says, okay, I confirm that code in production, that works. And then what happens is that Hubot detect that the branch that was deployed in production is now merged. So we can release the lock, we can give the lock to somebody else, and the process is just finishing. The next one in the queue gets to deploy then, and the process is over. And that's just that. Super simple. Do you have any questions? Yeah? Can you speak loud? Yeah, you. Git flow light. We use what we call GitHub flow. We use GitHub flow. I mean, Git flow is so much more complicated. You have long running branches. You might have to apply a patch to different branches. It's a great opportunity to fat finger something. So we like to make things the easiest possible. The easiest way possible. Other questions? No? Oh, yeah, sorry. I can see. Yeah.
Have any rollbacks?
Do we have any rollbacks? Yeah, that happens. That happens. And rollbacking is just deploying master again. That's it. I mean, we very often have the question about also database schema. And we created a framework, again, open source, called Ghost. We're using MySQL. So we have a tool to migrate schema without any interruption. And we leverage that a lot to be agile at the schema level. So we can change the schema. There's no interruption, no restart whatsoever. It's pretty efficient as well. Yep.
What if the new version requires a migration of the data? So you cannot roll back easily to the master version?
So whenever there is the question is about what happens when you have both a schema change and a feature change. So we're doing things in 2 steps. So we will first do the schema migration and make sure that the schema migration is, the code needed to access the data. It's a pretty straightforward layer that we have, so it's easy to change that without messing up anything. And then we can build features on top of that. So it's like there is a separate pull request for that, and it's quite easy to do that. It's just a matter of breaking down the work in ways that cannot fail, basically. Yeah.
You said your branch should be on top of the master.
Yeah.
But how do you make it? Do you use rebasing, verging?
So yeah, to make sure the branch is on top of master, are we using rebasing or So there are several ways. So the developer can rebase himself, his branch himself, if he wants. But also Hubot, if there's not much conflict, Hubot can create a fake, a virtual branch that is the result of the rebase. So Hubot can do that for me. I don't necessarily have to do that when deploying. Hubot can do that automatically as well. So, but later on, when the developer wants to merge his pull request, it's up to the developer to decide what he or she wants to do. We don't have a religion at GitHub about merge or rebase. We don't care. The history is in the pull request. The history is not in the Git log. So we don't care about that. If somebody is raising his hand and I'm not seeing it, oh yeah, okay. Because I got the light in my face so I can see. You have to scream. Sorry? Can you speak a little louder?
So I think a lot of people, me included, probably wanting to try and kind of get this over to our managers when we get back to work, of how like we should be talking about code a lot more than we're probably writing it. So just to give us an idea, like what percentage of time does your average GitHub employee spend talking about code versus writing it?
That's tough to. So the question is, what the amount of time we spend talking about code rather than writing code, and to have that kind of social coding. That's what we call it, social coding activities. It's hard to tell. It's really hard to tell. But I would say that we spend probably at least 1 or 2 hours talking, discussing about each other's code in a given day. Yeah. But I mean, the benefits, it's better design, better code, so less bugs at the end of the day, and less time refactoring things. So there's I mean, it really pays off. But yeah, I would think 1 hour to 2 hours a day. Yeah. I can see. Oh yeah, I can see you. So, but I saw a hand.
Does everyone have the same permissions when they interact with Hubot?
Oh, good question. No, because we don't want our salespeople to deploy code. So there's 2 levels of security, I'd say, or 2 ways to enforce security. First of all, Hubot has different behaviors in different Slack rooms. So there are some commands that are not available in certain Slack rooms. So if you have access to that Slack room, you will be able to trigger these commands. And then for the most sensitive ones, we have a second factor authentication. So we receive a notification on our phone to confirm that we are the person who is typing that command on Slack. And we need to acknowledge that on our phone, and then the command is getting triggered. So yeah, we secured that a little bit. We thought that leaving everything up to Slack for our own security was not such a good idea. We have 2 minutes left. Yeah.
Do you do postmortems on production files?
Yes, we do that. We do whenever something is going wrong, we're doing postmortem, or whenever a large project is over, we do postmortems as well to learn from that. Yes, definitely. We do a lot of them. Yeah.
When you said that you deploy like 100 times in a day, this is to master or is to carry?
To master. I mean, to production.
It doesn't happen that there are bugs you master if you deploy like 400 times a day.
S-
You said when you have a bug in production, you roll back to master. But if you are merging to master all the time, what do you roll back to?
Well, yeah. I mean, if we have an emergency, like we see that something is really wrong and we need to act quickly on that, then we know that we can redeploy master. But obviously, sometimes we have bugs that are still existing in our code base. Then it's just the same cycle again. We create a pull request, we change the code, and we push that code in production to fix the bug. And what we can do to avoid waiting in the queue when it's an emergency is that we can leapfrog everybody and do an emergency deployment. So we can just say, okay, I'm the first. Whatever is happening right now, just get out of my way, and I need to push that code in production right now. So. We fix the bug, yeah. Yeah, because the feature might still be useful, so, yeah.
Do you deploy to different geographical locations to reduce the impact or scale impact?
No. It's, everything is in the US right now, and I cannot give you all the details, but no, not yet. We're doing stuff to improve the distribution over the world, but right now it's a fairly narrow geography. I mean, several places, but not several continents. All right, I think my time is up. I'll be on the booth. We have a GitHub booth over there. We have stickers, and I can get more questions. Thanks, everybody.